Welcome back, students. We'll be looking at section 4.3, terminology for solving systems of linear equations by elimination. So in the last section, we solved linear equations through substitution. We're now going to learn about solving them through elimination, which is just a different method to solve the same type of problem. So in our first two blanks, we're going to put elimination method. The elimination method uses the addition property of equality to solve systems of equations. So let's look at the steps. Step 1, problem adjustment. Make sure the equations are in the ax plus by equals c form. Remember, that's the standard form. So we want our x's and our y's to be on the same side, okay? Choose a variable to eliminate. Determine how the problem needs to be adjusted to allow for the variable to be eliminated when the two equations are added to or subtracted from each other. Hint, one set of variables should be opposites to cancel each other out. And we'll see examples to show you what I'm talking about when I mention about making sure they match. Step 2, add to or subtract the two equations from each other to create a single equation with only one variable. Step 3, solve for the one variable. Step 4, substitute that value found in step 3 in one of the original equations to find the value of the other variable. And then step 5, check your answer. Verify that the values found work in both original equations. Now let's look at an example that's going to take us through each of those steps. So remember, step 1 is to look at our two equations and decide which variable, the x or the y, do we want to eliminate. And depending on which one we want to eliminate, that's going to determine which equation we must alter, we must adjust. In this first example, we actually don't need to adjust anything because I noticed that my y's are matching but opposite signs. One is a positive y, one is a negative y. So I know that if I add these two equations together, they're going to cancel each other out. And so what I'm talking about is right here. Step 2. If I add these two equations together, I say x plus x gives me 2x. Y plus a negative y gives me a 0. They canceled each other out. And then 8 plus 2 gives me 10. Okay, so again, what we're doing is taking the two original equations and we're adding them together to cancel out those two y's. So I end up with 2x equals 10. I only have an x now. I don't have an x and a y, so I can actually solve for the value of x. I'm going to divide both sides by 2, and I get x equals 5. Pretty simple so far, right? All right, well, step 4 says substitute the value of x into one of the original equations to find the value of y. So I'm going to pick one. I'm going to pick, let's just pick the first one, okay? So x plus y equals 8. I'm going to substitute that 5 in for my x. Subtract the 5 from both sides. I get 0 plus y equals 3, so I get y equals 3. All right, so now I have my x and my y values, so I'm going to put those in my solution, 5 and 3 here. Step 5 says verify the solution found, verify that the solution found is a true solution by checking your answer. So we're going to plug in our values into both of these equations and see if it does work out. So x plus y equals 8, and I'm going to draw a line down here. X minus y equals 2. All right, so I'm going to plug in 5 plus 3 equals 8. 8 equals 8. So yes, works on that side. 5 minus 3 equals 2. So 5 minus 3 is 2. So yes, it works on that side as well. So we have, in fact, found our solution. Now I want you to notice there was a lot less steps in this problem compared to the substitution problems of the previous section. both methods are valid methods, and depending on the problem, one might be better than the other method. So what I want you to notice as we go through these is that you can use either method, and depending on the problem, like I said, one might be better than the other, and you'll determine which method you want to use to solve the same types of problems. All right, let's look at the next example. Y plus 11 equals 2x, and then we have 5x equals y plus 26. Now remember, in the first step, we're supposed to get our formulas, or not our formulas, our equations into standard form, the ax plus by equals c form. So I'm going to write that up here just as a reminder. This is the form we need them in. So we're going to adjust both of these. So y plus 11 equals 2x. I'm going to flip the problem. All right, so now I can see that I need to subtract the y from both sides to get it on the same side as the x, and I get 2x minus y equals 0 plus 11, which is 2x minus y equals 11. All right, so that's one equation. Now we need to adjust our other one. So we have 5x equals y plus 26. Again, I need to subtract my y to get it on the same side. So I get 5x minus y equals 0 plus 26. And I get 5x minus y equals 26. That's my other equation here. So on step 2, I'm going to rewrite, and I'm going to have the first one that we did, 2x minus y equals 11. My other one was 5x minus y equals 26. All right, so the first thing I notice is I have single y's here, but they're not in opposite signs. So I need to adjust one of these equations so that my y will be a positive y rather than a negative y. So what I'm going to do is I'm going to multiply my, here I'm going to do it in a different color so you can see. I'm going to multiply this top equation by a negative 1. Okay, so I'm going to rewrite these. I get a negative 2x plus y equals negative 11. And my other one stays the same. I didn't do anything to it. I've only adjusted the top one. Now I can add my two equations together. Negative 2x plus 5k is a positive 3k. A y plus a negative y is a 0. And negative 11 plus 26 is going to give us a positive 15. Okay. Step 3 says take what we just did and find the value of x. I'm writing k's and it should be x's here. All right. Divide by 3 and we get x equals 5. Now we're going to take that and plug it into one of our original equations. I'm going to pick the top one. Y plus 11 equals 2 times 5. So y plus 11 equals 10. Subtract the 11 from both sides. Y plus 0 equals negative 1. So y equals negative 1. These are our two values. So we have 5 and negative 1. But we need to verify that they are, in fact, correct. So y plus 11 equals 2x. The other equation was 5x equals y plus 26. All right, so let's substitute in our values. Negative 1 plus 11 equals 2 times 5. We get 10 on this side and we get 10 on that side. So yes, that works so far. 5 times 5 equals negative 1 plus 26. We get 25 equals 25. So yes, again, we have found our correct values of 5 and negative 1. Example 3. We have 4x minus 3y equals 6. And we have 2x minus 7y equals negative 8. Remember, step 1 says to get these into the ax plus by equals c form. Both of them are already in that form, so we can skip that step and just write our equations over here. So we have 4x minus 3y equals 6. And we have 2x minus 7y equals negative 8. All right, so now what we've got to decide is which pairing, our x's or our y's, will be the easiest to make match each other with opposite signs so that we can cancel them out. I can get my x's to both be a 4 by just multiplying my second equation by a negative 2 so that we have a 4 with opposite signs. Or I can multiply my y's, the top one by a 7 and the bottom one by a 3, so that we get opposite signs of 21y to cancel out. Then I'd have to multiply both equations. So it seems like getting our x's to match is going to be less work. So let's go that way. So I'm going to multiply this bottom equation by negative 2. And so what I end up with is my first equation doesn't change. So I'm just going to rewrite that. We didn't multiply it by anything. Negative 2 times 2 gives me a negative 4x. Negative 2 times negative 7 gives me a positive 14y. And negative 2 times negative 8 gives me a positive 16. Now our 4x's cancel. Negative 3 plus 14 gives me a positive 11y. And then 6 plus 16 gives me a 22. Step 3, I'm going to take what we just found and solve for y. So divide by 11 and get y equals 2. Take that, plug it into one of the original problems. So I'm going to pick the first one, 4x minus 3y equals 6. 4x minus 3 times that 2 equals 6. So I get 4x minus 6 equals 6. Add 6 to both sides. I get 4x plus 0 equals 12. All right, divide both sides by 4. And I get x equals 3. All right, so we have our values of 3 and 2. Don't put them in the wrong location. Recognize that we found our y first and then our x. So we need to make sure we put them in the correct order in our solution. And now we can actually check our answer. So we have 4x minus 3y equals 6 for one of them, and 2x minus 7y equals negative 8 for the other one. Oops. All right, so plug in our values. I have 12 minus 6 equals 6. 6 equals 6, so yes, that one's correct. 2 times 3 minus 7 times 2 equals negative 8. I get 6 minus 14 equals negative 8. So that is negative 8 equals negative 8. And yes, we have found the correct answer. Example 4, we're going to go through this problem twice. And the reason is because I want to show you option 1 and option 2 to show you that it doesn't really matter which one you pick, both will work, okay? So in option 1, let's look at our equations. We have 2x plus 3y equals negative 15, and we have 5x plus 2y equals 1. Both of them are already in this form, the standard form. So in option 1, I'm going to go with canceling out our x's first. In option 2, when we do the problem again, I'm going to cancel out the y's, just to show you it doesn't matter. But this one, let's start with canceling out our x's first. So I'm going to rewrite the problem. I have 2x plus 3y equals negative 15. And then I have 5x plus 2y equals 1. All right, to cancel out my x's, I need them to become a matching number. 2 and 5 are factors of 10. So that's what my goal is. So my top one, I'm going to multiply it by 5. My bottom one, I'm going to multiply it by a -2 because I need them to be opposite signs. So I end up with 5 times 2x gives me 10x. 5 times 3 gives me a positive 15y. And then 5 times -15 gives me a -75. My other equation, I have -2 times 5x gives me a -10x. -2 times 2 gives me a -4y. And then -2 times 1 gives me a -2. Now I'm going to add my equations together. The 10x's cancel each other out. The y's become plus 11y. And I get a -77 on this side. So now I'm going to bring this down here so we can do step 3. Divide both sides by 11. And I get y equals -7. I'm going to take that and plug it into that first equation. So 2x plus 3y equals -15. Replace my y value. I get 2x minus 21 equals -15. Add 21 to both sides. I get 2x plus 0 equals 6. So 2x equals 6. Divide both sides by 2. And I get x equals 3. All right, so we have our two values. We have 3 and we have -7. So again, we're going to check our work and make sure we have the correct values. So 2x plus 3y equals -15. And then on the other side, I had 5x plus 2y equals 1. All right, so plug in 2 times 3 plus 3 times -7 equals -15. I get 6 plus a -21 equals -15. That gives me -15. And so yes, so far, so good. We're good. Let's check this one. 5 times 3 plus 2 times -7. We get 15 plus a -14. And that is, in fact, 1 equals 1. So we are good there. All right. Now let's go to option 2. Because I said I wanted to show you, well, what if we had chose to cancel out our y's first rather than our x's? So again, we don't have to do step 1. They're already in this format, so we don't have to worry about that. Let's go ahead and write over here our equations. 2x plus 3y equals -15. 5x plus 2y equals 1. I'm going to, let's see, multiply by 2 on the top because 3 and 2 are factors of 6. So I'm going to multiply this 3y by a 2. My second equation, I'm going to multiply it by a -3 because I need that to become a -6, a 6 with an opposite sign. All right, so I get 2 times 2 is 4x. 2 times 3 is 6y. 2 times -15 is -30. On our second equation, I have -15x. -3 times 2 is a -6y. -3 times 1 is a -3. Add those together. My 4x minus 15x gives me a -11x. My y's cancel out. End up with -33 here. So I have -11x equals -33. Divide by -11. And I get x equals 3. Is that what we got above? Let's check. Ah, yeah, it is. So far, it's working out the way I said it would. All right, let's look at if we choose 5x plus 2y equals 1 to find our y value. 5 times 3. We get 15 plus 2y equals 1. Subtract 15. I get 0 plus 2y equals negative 14. Divide both sides by 2, and I get y equals negative 7. Is that what we got above? Yes, we did. We got y equals negative 7. So we've got the same values. X is 3. I'm going to write them in my solution. Y is negative 7. We've already checked our answers in way number 1. So we're not going to do that again. But it just verifies what I told you. It doesn't matter if you choose to get rid of your x's first or your y's first. As long as you do it properly, you should get the same answer that you would if you'd chosen the other. All right, so solving special systems by elimination. These will be our last 2 examples for our new terminology. We have 2x plus 4y equals 5 and 4x plus 8y equals negative 9. They're already in the proper format, so we don't have to do that. So we're good there. I'm going to rewrite them over here. 2x plus 4y equals 5. 4x plus 8y equals negative 9. I'm going to choose to get rid of my x's. So I'm going to multiply this top by a negative 2. I end up with a negative 4x minus 8y equals negative 10 when I multiply that through. Rewrite my second equation. When I add them together, my x's cancel. My y's also cancel. And then I get negative 10 minus 9 gives me a negative 19. So I end up with 0 equals negative 19. Those don't equal. That means no solution. But we want to check it. Remember, we want to verify that what we did was correct. So what I'm going to do is get both of my equations in my y, or my slope-intercept form, which is the y equals mx plus b. So we can compare our slopes and our starting points, our b's. So let's take the first one. 2x plus 4y equals 5. Subtract 2x from both sides. I get 0 plus 4y equals negative 2x plus 5. Rewrite that. Divide both sides by 4. And I get y equals negative 1/2 x when I reduce that fraction, plus 5/4. So that's our equation of a line for the first one. Let's do our second one. 4x plus 8y equals negative 9. Subtract 4x. I get 0 plus 8y equals negative 4x minus 9. All right, divide everything by 8. I end up with y equals negative 1/2 when I reduce that fraction, minus 9/8. All right, so I noticed that they have same slope, but different y-intercepts, different b's, okay? And what that tells me is we have parallel lines. If we have parallel lines, we have no shared solutions. So we have verified that we did our problem correctly. Example 2, 4x minus 6y equals 10. Negative 10x plus 15y equals negative 25. All right, again, we have them in the proper format, so we don't have to worry about that. Step 2, I'm going to rewrite our equations here. All right, so I've got to decide, do I want to get rid of my x's or my y's? I'm going to get rid of my x's. And I need to find a common multiplication fact between 4 and -10. They are both factors of 20. So that's what I'm going to go for. So to get 4 to be a 20, I need to multiply by 5. To get -10 to be -20, I need to multiply it by 2. I end up with 5 times 4, which is 20x, 5 times -6, which is -30y, and then 5 times 10 is going to give me 50. My next equation has 2 times -10, which is -20x. 2 times 15 is +30y. And then 2 times -25 is a -50. All right, so when I add these together, my x's cancel. My y's cancel. And my other side cancels. 50 plus a -50 is a 0. So I end up with 0 equals 0, which is an infinite solution set. But let's check it, just like we did the other. Let's get it into the y equals mx plus b form so we can compare our slopes and our y-intercepts and verify that they are in fact the same line, which is what infinite solution tells me. So I'm going to take my 4x minus 6y equals 10 minus the 4x from both sides. I get 0 minus 6y equals -4x plus 10. All right, divide everything by -6. I end up with y equals 2/3 x minus 5/3 when I reduce those fractions. All right, so we've got that one. Now let's do the other one. I have -10x plus 15y equals -25. I'm going to add the 10x to move it to the other side. I get 0 plus 15y equals 10x minus 25. Divide everything by 15. I get y equals 2/3 x minus 5/3 when I reduce those fractions. And look at that. We have the same slope. Here, let me change that to a different color. We also have the same y-intercept, or b is the other way we call it. So that means we have the same line. So the way we write our solution is xy such that y equals 2/3 x minus 5/3. All right, let's look at our quote for this section. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. Arthur Conan Doyle. All right, guys, I hope you're having a great week. I'll see you in the next video. Bye.